Okay, time to look at some more inequalities and see what we can establish from them. As a reminder from our last lesson, we want to treat this just like it was an equal sign and solve like we're solving an equation, but this time it's an inequality. So, to get the x by itself means I need to get that entire 5x term by itself. So add 3 to both sides, leaving you with 5x is less than 30. Divide both sides by 5 to get x is less than 6. And again, keep practicing with your graphing. There's your 6. 0 would be over here somewhere. Open circle, shading to the left. Open because it's less than, to the left because it's less than. Okay? In problems like these, though, where I have fractions everywhere, what I would suggest is finding a fraction, or finding a number that you can multiply this whole thing by to get rid of the fraction. Well, if I multiply this by 2, I would get rid of this denominator 2, but it wouldn't help my 3's here. So I also need to multiply by 3. So 2 times 3 is 6. I'm going to multiply every number by 6. So the way I do that, 6 times 1 is 6, divided by 2 is 3. So that'll become 3x. 6 times 1 is 6, divided by 3 is 2. So plus 2. Keep my sign. 4 times 6 is 24, divided by 3 is 8. Or you can say 6 divided by 3 is 2. 4 times 2 gives you 8, either way. And now I solve it just like I had before, subtracting 2 from both sides. 3x is bigger than or equal to 6. Divide both sides by 3. X is greater than or equal to 2. So here's your 2. 0 would be there. Filled in circle because it's or equal to, and shading off in the direction of the arrow. Okay? Now, here's a couple problems that'll have some special cases here. In this first one, you got a W on both sides. Anytime you get a variable on both sides, like any of these top ones, I need to first try to get all the variables on the same side. So with this one, if I subtract a W from both sides, well, those are going to cancel out, right? Well, they're going to cancel out here too. I'm going to leave 6 is greater or less than or equal to negative 6. Is that a true statement? Definitely not. 6 is not bigger than negative 6. This is definitely false. That means no matter what I plug in, I will not get a true answer. I will not get something that is mathematically correct. So this means there are, again, no solutions like we've seen before. Okay, in the second one, very common mistake is people want to divide by s in these problems. No, not at all. You cannot divide by a variable. We're not going to divide by a variable in order to solve by it. What I will do, just like over here, I'm going to subtract something from both sides. I'm going to subtract 10s because I'd rather subtract 10 than 12 because now I'll get a positive 2s. That goes away, so all I'm left with is 0. Divide both sides by 2, well, 0 divided by anything is still 0. So I get s is bigger than or equal to 0. So there's your 0, filled in, shading to the right. Okay, in the third one here, I can subtract a 3k or a 2k. I'm going to subtract 2k from both sides, and that's going to leave me with 1k minus 4 is less than 1. I'll add 4 to both sides, so k is less than 5. So here's 5, open to the left. Okay, on the bottom here, why don't I let you go and actually try them? I would suggest you pause the video, give these two a try, and see what happens. Okay, see how we did. You have a minus 2x here, that's what I need to get by itself, so I need to subtract 6. It's a positive 6 here, I need to subtract 6 on both sides. Leaves me with negative 2x is bigger than negative 2. Divide both sides by negative 2, so x is something to 1. I divided by negative, I'm switching my sign. X is less than 1. So if I graph this, going to do color up here. If I graph this, x is less than 1, there's 1, there's 0, shading to the left for sure. Okay, and in this last one, I'll first distribute the 2 through, so 2x plus 6 will be greater than or equal to 2x plus 1. And you should notice this is kind of like the first one we did. I need to subtract a 2x to get all the x's on the same side. And when I do that, these are going to cancel out and leave me with 6 is greater than or equal to 1. And what happens here? Well, in the first one we said we had a false statement because 6 was less than negative 6. That's not true. In this one I have 6 is bigger than 1. Is that true? Absolutely. This is a true statement. That means this is, we can say, infinite solutions. We can say something like, sometimes we say all real numbers, all real hashtags. We have lots of different ways that we can express this. Whatever way you prefer is absolutely fine. But the main thing is every single possible number you plug in will be true. Sometimes we like putting the kind of cool looking R, meaning all real numbers as well. So there's some more inequalities for you.